All right, I'm going to be following this document that says solving logarithmic equations. If you were in my class, my college algebra classes, you will receive this at the appropriate time, or you would have received it at the appropriate time. Okay? The steps that I will be following are on this paper, and I'll go ahead and put it close to the camera if you want to copy them down. And then I'm going to start showing the examples. So I'll start with the first two. So I'll start with the basic ones that are on the first page. The trick, I'll go ahead and copy the first. I copy the equations for the basic ones every time. So you dump the log, the base 4 goes to the other side, and the 3 will become an exponent. So we end up with x minus 7 equals 4 cubed. Okay? Teacher's figure speech, we dump the log, the base 4 goes to the other side, the 3 jumps up to make room for it. Mathematically speaking, that's not what's happening, but hopefully it'll help you remember. Dump the log, the 4 goes to the other side, the 3 jumps up to make room for it. Okay? So, having done that, we have x minus 7 equals 4 cubed, which is 64. Add your 7, and x equals 71. Same idea here. Okay? We have log base 5 of 51x plus 13. Dump the log, the 5 goes to the other side, the 4 jumps up to make room for it. Okay? So we end up with 51x plus 13 equals 5 to the 4th. 5 to the 4th power. So we have 51x plus 13, okay, 5 to the 4th, pretend I don't know the answer to that, 625. Subtract your 13, and 51x is 612. Divide off your 51, and x equals 12. All right, example 3 isn't on the board yet, so I'll go ahead and add it. We have log of 3x plus 1 equals 2. Let me go ahead and move that down out of the glare. Okay, it's entirely in the glare, so I think I'll go ahead and move it. All right, so here goes. Do. That's actually equivalent. If you don't see a base, you assume 10. So it's log base 10 of 3x plus 1 equals 2. Dump the log, the 10 goes to the other side, the 2 jumps up to make room for it. So now I have 3x plus 1 equals 10 squared, which is 100. Subtract the 1. 3x is 99. Divide off the 3, divide off the 3, x is 33. Finally, the last basic example is example 4. It's a little bit on the more advanced side, but we'll go ahead and do it anyway. Okay, as a basic. So natural log of 5x minus 2 is 3. Okay, this is actually equivalent to log base e of 5x minus 2 equals 3. Okay, so I will dump the log. The 3 will go up into the exponents. So we'll have 5x minus 2 equals e. So the base e is still the base, and the 3 is now an exponent. So next step, go ahead and add the 2. So we have 5x equals e cubed plus 2, then divide out the 5. And x equals e cubed plus 2 over 5. So that's the exact solution. Okay? Approximate. So this is exact. This is approximate. X is approximately equal to, I'll take e cubed. I get 20.0855, blah, blah, blah. Add 2. That gives me 22.0855, blah, blah, blah. Divide by 5. That gives me approximately 4.417. Okay, I just chose to round to 3 decimal places. It didn't say, it didn't give me a specific value to round to, so I'll go ahead and leave it as is. All right. Now, the next part is to move on to the more exact, to the more advanced equations. Let me go ahead and get this erased. Advanced. And I am skipping certain problems. Okay, I am skipping examples skipping example 3. No, I think I'll just skip example 5. Skip examples 5, 6, and then I'll go ahead and start with example 1. Okay, so let me go ahead and put this information on the board. So here's the second page. There are certain logarithm rules that you need to know how to use, and the steps are on here. Okay. Again, if you want to pause this and copy this, I'm okay with that. And then it's go time. So example 1, I have log base 6 of x plus log base 6 of x minus 9 equals 2. Okay, now there's a sum product relationship. If you have a common base and you're adding the logarithms, you can combine them into a product. So this is log base 6 of x times x minus 9. Okay, if common base, if you're adding logarithms, you can combine them into the logarithm of a product. Okay, so that gives me log base 6 of x squared minus 9x equals 2. All right, I'm going to dump the log. The 6 goes to the other side. The 2 jumps up to make room for it. I have x squared minus 9x equals 6 squared, which is 36. Okay, I want to solve these by factoring if at all possible. So I'll bring one side to 0. I have x squared minus 9x minus 36 is 0. Okay? So, it's factorable. I got x and x. The pair of factors of negative 36 up to negative 9 are negative 12 and positive 3. Okay? So I have x minus 12 equals 0, x plus 3 equals 0. So go ahead and add your 12, and x equals 12. Subtract your 3, and x equals negative 3. But both of these are maybes, because there's a good chance that one of them doesn't work. Folks, if you have multiple logarithms and a number, you must check. Okay, you must check your proposed solutions. Check. We'll start with the lower number because it's the one that's least likely to be valid. We'll start with x equals negative 3. So we're going to use the original form of the equation. Log base 6 of negative 3 plus log base 6 of negative 3 minus 9. I want to know if it equals 2. Now, folks, I don't actually have to plug and chug here. Okay, it doesn't matter that much, because really all I'm looking for is valid or invalid. Okay, this is invalid. Invalid in the real numbers. Okay. Logarithms of negative numbers are invalid in real valued equations. Okay? So I don't even have to do this one. That's bogus. Okay? I can confirm that this also will be bogus. Invalid. Log of a negative, log of a negative. It's out. Okay? X does not equal negative 3. Okay? Next, I'll check x equals 12. That was the other perspective solution. So I have log base 6 of 12 plus log base 6 of 12 minus 9. I want to know if it equals 2. Okay? That's valid. It's a logarithm of a positive number. Okay? This is log base 6 of 3. This also is valid in the real number system. Okay? Log of a positive, works both of them work. X equals 12 is the only solution. Okay? Now, a common mistake among students, well, we'll go ahead and do the next problem. Okay? So let me go ahead and put these another fact up there. Facts. Number 1, log base b of m plus log base b of n equals log base b of mn. And number 2, log base b of m minus log base b of n equals log base b of m over n. Okay? We use this one with example 1. So here's example 2. I have log base 6 of x plus 4 equals log base 6, sorry, let I'm having trouble copying remembering my own work as I copy it. Minus log base 6 of x minus 5. Okay, what we're going to have to do is if we've got logarithms on both sides, if we have logarithms on both sides, we need to bring them to one side. So I'll go ahead and bring them to the left. So I'll go ahead and add to this logarithm. And many times you'll get an equation that starts looking like this. Okay? Many times it will start looking like this. And this is right again for this property right here. So we'll have log base 6 of this times this. Okay? I'm going to dump the log. So actually what I need to do is I need to go ahead and do this polynomial multiplication. X squared, outer terms minus 5x, plus inner terms plus 4x, last terms minus 20, equals 2. So that gives me log base 6 of x squared minus x minus 20 equals 2. Okay, so I'll go ahead and copy it up here. Log base 6 of x squared minus x minus 20 equals 2. So next I'm going to dump the log. The 6 goes to the other side, 2 will go up and make room for it as an exponent, and we'll have x squared minus x minus 20 equals 36. Okay, we want to solve this by factoring, so I'll subtract the 36. We have x squared minus x minus 56 is 0. It's factorable. The pair of factors of negative 56 out to negative 1 are negative 8 and positive 7. So I set them both equal 0. Add your 8. And x equals 8. Subtract your 7. And x equals negative 7. Maybe. Because there's a good chance one of them won't work. It's probably going to be the lower number. So now I'm going to check. Remember, folks, logarithms of negative numbers are invalid in the real number system. So we have log. So first I'm going to start by checking x equals negative 7. I want to know if log base 6 of negative 7 plus 4 equals 2 minus log base 6 of negative 7 minus 5. All right. And I want to make sure this is on camera, still on camera, and it's not, looks like. Now it is. Okay. So this is log base 6 of negative 3. Let me put a question mark there. Okay, now this makes matters very simple. This is invalid in the real number system. This also is invalid in the real number system. Okay, so next, I think I'll push this back to make it a little easier for everything to see. Okay, next I'll check the x equals 8. Log base 6 of 8 plus 4, does it equal 2 minus log base 6 of 8 minus 5? So that's log base 6 of 12. This is log base 6 of 3. This is logarithm of a positive number. It's valid in the real numbers. This also is valid in the real numbers. So x equals 8 is our only solution. All right. Let me get all this off the board and proceed to example 3. A common mistake among students is to assume that the negative, if it's a negative, it won't work. You have to check these, folks. Example 3 is designed to illustrate that. Example 3. I have log base 3 of x plus 29 plus log base 3 of x plus 5 equals 4. All right, do. We're going to use this rule right here. So I have log base 3 of x squared, or sorry, of x plus 29 times x plus 5 equals 4. So that gives me log base 3 of x squared plus 5x plus 29x plus, I better multiply that out, 145 equals 4. So that gives me log base 3 of x squared plus 34x plus 145 equals 4. Okay? Go ahead and copy it again. Dump the log, the 3 goes to the other side, the 4 will jump up to make room for it. Okay? So we'll have x squared plus 34x plus 145 equals 3 to the 4th, giving me x squared plus 34x plus 145 equals 81. I'll go ahead and copy it over here as is. Okay, ideally we'll solve these by factoring. So I'm going to go ahead and subtract the 81 to bring one side to 0. And we have x squared plus 34x plus 64 equals 0. All right, so I got x and x. The pair of factors of 64 that have the 34 are 2 and 32. Okay, so I have x plus 2 equals 0. X plus 32 equals 0. Okay, subtractor 2, x equals negative 2. Subtractor 32, and x equals negative 32. Okay, and these are maybes, because they may not work in the original equation. So they need to be checked. All right, so I'll start with the lower number because it's the one that's most likely to be the one that doesn't work. So I have log base 3 of negative 32 plus 29 plus log base 3. I'm gonna go ahead and move all that over. Now we need to check these. So x equals negative 32 is the lower number. We'll start with that. So I want to know if log base 3 of negative 32 plus 29 plus log base 3 of negative 32 plus 5 really does equal 4. Okay? That's a question mark for those of you who are wondering what that symbol is. Okay? So this is going to be log base 3 of negative 3, and I'm done. Okay, that's bogus. Invalid. Okay, so that's out. I'll do the other one just for the sake of thoroughness. Okay, also invalid. Okay, logarithms of negative numbers do not work in the real number system. Okay, next we'll try x equals negative 2. Log base 3 of negative 2 plus 29 plus log base 3 of negative 2 plus 5. I want to know if it equals 4. Okay, well, this is log base 3 of 27. This is log base 3 of 3. Well, I don't need to worry about any of the other stuff, okay? This is valid. It's the logarithm of a positive number. This also is valid. It's the logarithm of a positive number. So x equals negative 2 is my only solution. Okay? And I'm going to go ahead and get this off the board. And move on to example 4. All right. Natural log of 17x plus 10 plus natural log of 5x plus 14 equals the natural log of 85x squared plus 203. Once again, we're going to follow this rule. Now, folks, because this is only logarithms, the only expressions here are logarithms, we won't actually need to check this, okay? No need to check, because it's all logarithms, okay? So here it goes. We're going to follow this rule for the left side. So this is going to be the natural log of 17x plus 10 times 5x plus 14 equals the natural log of 85x squared plus 203. Go ahead and FOIL this out. 85x squared plus 17 times 14 plus 238x plus 50x plus 140 equals the natural log of 85x squared plus 203. All right, so I'll go ahead and finish this multiplication. 85x squared plus 288x plus 140 equals the natural log of 85x squared plus 203. Okay. Now, if the natural log of this equals the natural log of that, that requires that these two would have to be equal. Okay, now what we're going to do next, okay, there's some noise in the hallway. I'm going to close the door. Okay, so I'll go ahead and cancel the quadratic term on this side. So we have 288x plus 140 is 203. I'll go ahead and copy it over here. 288x plus 140 equals 203. Subtract your 140, and 288x equals 63. Divide off the 288. Both of these are divisible by 9. So this is 7, and then 288 divided by 9, 7/32. Okay? And again, because it's nothing but logarithms, we don't actually need to check. Okay, so I'm going to move on to example 7. Okay, so example 7, I have log base 3 of x plus 1 minus log base 3 of x minus 2 equals 4. Okay, so that's a subtraction relationship, so I'll be using this rule. Log base 3 of this over this equals 4. Okay, following this procedure right here. So, I'm now going to go ahead and dump the log. Dump the log, move the 3 to the other side, the base 3 to the other side, the 4 goes in the exponent. So x plus 1 over x minus 2 equals base 3 to the 4th, which is 81. So x plus 1 over x minus 2 is 81. Go ahead and copy it over here. All right, now you could clear the fractions using the LCD, but most of my students prefer to use a proportion. They'll convert this into 81 over 1, and they'll take this times this equals 81 times x minus 2, like so. Okay, so this gives me x plus 1 equals 81x minus 162. Okay, I got x's on both sides. I don't like that, so I'll subtract this 81x. And I have negative 80x plus 1 is negative 162. Okay? Subtract 1, negative 80x equals negative 163. Divide, so we'll end up with negative 163 over negative 80. So x equals positive 163 80ths. But folks, because we had logarithm, and a number, this is a maybe. Okay? Check. We'll use x equals 163 80ths, and I'm going to convert that into a decimal. So it's 2 point something. 163 divided by 80, 2.0375. Feel free to use a decimal approximation on these when we're checking. So this is going to be log base 3 of 2.0375 plus 1 minus log base 3 of 2.0375 minus 2. I want to know if it does actually equal 4. Okay? So, this is log base 3 of 3.0375. And this is positive 0.0375. Okay? I really don't need the minus in the other number, okay? Logarithm of a positive number, that's valid. Logarithm of a positive number, that also is valid in the real number system. So x equals 163 80ths, okay? Now let me switch to example 8. Okay, example 8, I have log base 5 of 7x minus log base 5 of x minus 4 equals 1. All right, so using this rule, we have log base 5 of 7x over x minus 4 equals 1. Okay, let me double check that I copied it correctly. I did. Okay, good. So, we will now proceed to dump the log. The 5 goes to the other side and the 1 goes up in the exponent to make room. So we have 7x over x minus 4 equals 5 to the first. Well, 5 to the first power is just 5. Go ahead and copy this over here. We have 7x, let me copy it a little bit more neatly. 7x over x minus 4 equals 5. So now we have 7x over x minus 4 equals 5 over 1. All right, so this times this, the diagonal, 7x times 1. Actually, let me take the number. 1 times 7x equals 5 times x minus 4. So 7x equals 5x minus 20. I got x's on both sides. I don't like that, so I'll subtract this 5x. 2x equals negative 20. Divide out the 2, divide out the 2, x equals negative 10, maybe. Because remember, we had logarithm, number. Okay, so now I need to check. So I want to know if log base 5 of 7 times negative 10 minus log base 5 of negative 10 minus 4 really does equal 1. Okay, and again, I'm not really going to have to calculate any logarithms. I just have to determine whether or not there are logarithms of positive numbers or not. So this will be log base 5 of negative 70. That's invalid. So x does not equal negative 10. So because that was the only prospective solution, there's no solution. And again, this would also be log base 5 of negative 14, also invalid. Okay? If it gives you a logarithm of a negative number, it's out. Okay? No solution. Because the only prospective solution, negative 10, gave us logarithms of negative numbers. Okay? So that won't work. All right, so let me get this off the board. Move on to example 9. Log of x plus 8 equals 6 plus log of x minus 7. All right. Now, we've got multiple logarithms and they're on the opposite sides of the equation. We need to get them to one side. So I'll subtract it off the right side. And that's a minus. I'll go ahead and subtract this one from the other log. So we'll have log of x plus 8 minus log of x minus 7 equals 6. Okay? The 6 that stays. So now we have this situation. Okay? Let me go ahead and get let's go ahead and combine this into logarithm of the product of x plus, this is not a product. We're using this relationship because it's subtraction. So logarithm of this over this. Oh, and by the way, because this is, no log is stated, this is actually log base 10. Okay, if no log is stated, it's base 10. So, I have log base 10 of x plus 8 over x minus 7 equals 6. So, I'm going to dump the log. The 10 goes to the other side, the 6 will go up in the exponent to make room for it, and I will have x plus 8 over x minus 7 equals 10 to the 6th power. Base 10, base 10. And that's going to be x plus 8 over x minus 7 equals 1 million. Okay, I'm going to go ahead and copy that up here. All right. As I said, most of my students like the proportion method. So I'll go ahead and change this to a fraction of 1. And this times this equals this times this. So 1 times x plus 8 equals 1 million times x minus 7. All right. So x plus 8 equals 1 million x minus 7 million. All right, I got x's on both sides. I don't like that. Okay, so I'll end up with 900, negative 900, and negative 999,000. Plus x plus 8 equals negative 7 million. Okay, next I'll subtract the 8. So I end up with negative 999,999x equals negative 7,000,008. So divide that off. X equals negative 7,000,008 over negative 999,999. The negatives cancel, leaving me x equals positive 7,000,008 over 999,999. The bad news, folks, is that you actually have to check. Maybe. Because again, folks, we had logarithm, logarithm, number. So now we need to check. Check. X is approximately equal to, so I'm going to use a decimal approximation, 7,000,008 divided by 999,999. 7.000015. Okay, does that fit on the screen? It does. Okay, so I'm going to plug in the original equation. Logarithm of 7.000015 plus 8. I want to know if it equals 6 plus log of 7.000015 minus 7. So let me go ahead and recopy it. So I have log of 7.000015 plus 8. I want to know if it equals 6 plus logarithm of 7.00015 minus 7. Okay, so this is logarithm, got my question mark, log of 15.0000015 equal, and then this is going to be log of 0.000015. That's a logarithm of a positive number. So this is valid in the real number system. This also is valid in the real number system. So x equals 7,000,008 over 999,999. And I'm done for this one.